This week's problem of the week starts with a definition of magic square and presents a sample 3x3 magic square where the sum of each row, column, and diagonal is 15. Then the problem solver is presented with a 4x4 grid with the counting numbers 1 through 16 in the grid, and the problem solver is told that if you change the position of just 4 pairs of numbers, you can make a magic square where each row, column, and diagonal has a sum of 34. And for this week's problem, we're going to turn to a spreadsheet. And here it is. As you can see, we've already set the spreadsheet up with the numbers 1 through 16 as they were in the problem. And the red numbers indicate the sums of the diagonals, rows, and columns. An examination of those sums shows that both of the diagonals already add up to 34. So the first move we're going to try is a move that will keep the numbers in the diagonals so the diagonals don't change. So why not trade the 1 with the 16 as we're going to do here and see if that gets us closer. Yes, it seems to, but that's not enough. So let's trade the other 2 corners, the 4 and the 13, and see what we get. And as you can see, we've got several more 34s. And in fact, the only numbers left that we can mess with without affecting the 34s we already have are the 4 right in the middle, the 6, the 7, the 10, and the 11. So let's change those just the way we changed the others. We'll switch the 6 with the 11 and see what happens, and we'll also trade the 7 with the 10, and if we're lucky, we've used a little trial and error plus a little bit of reasoning, and there is the solution to this week's puzzle.